Hey guys, it's Ken here from Talk3D, and today I have with me Ben from BASF, Business Development Manager, and Emma, Technical Specialist from BASF, who are here to talk about their advanced materials in their filament lineup. Welcome, guys.
Yeah, thanks for having us.
Yeah, thanks, Ken.
Awesome. So now some of the people watching may not know, but who is BASF?
Yeah, so BASF, as a whole, is a chemical company. They make raw materials for just about any industry you can think of. A lot of the stuff that you probably are touching in your everyday life is made by BASF, and also really big in the automotive industry as well.
I think you're downplaying it a little bit. BASF, even bigger than that, right? And it goes back how many years, Ben?
Well, the 3D printing team started back in 2017. So it became its own entity that is actually part of BASF, but by being in its own entity, you're able to be a little quicker, a little faster. As you can imagine, BASF as a company is huge, a lot of processes in place. And with 3D printing being so dynamic and really moving so quick and fast, we needed to be able to have some of that freedom in order to operate.
So tell me about your group, the Forward AM group.
So the Forward AM group, ultimately, we represent all three of the major material types. So Emma and myself are part of our additive extrusion solutions group. We also have a powder bed fusion team as well as a photopolymers team. So Forward AM is kind of the encompassing product umbrella of the 3D printing offerings, in addition to services within the BASF 3D printing team.
And you guys are from the Ultrafuse group, specializing in
Filaments. So the product line we represent is, as Ken said, our Ultrafuse line, and it is all of our filaments.
And I think, do you know how many filaments you currently have in your portfolio right now?
Yes, so we have 23 products in our portfolio. It's the largest portfolio of the three material types.
And then you have
BASF.
2.85 and 1.75.
Yes, our logistics team hates us the most.
Plus a lot of different colors, a lot of spool sizes. There's a lot of variations of that portfolio of materials too.
Yeah, I mean, just one product could be many, many SKUs if you multiply all the colors and sizes that you have.
Yes.
For sure.
So before we get into all of that, tell us a little bit about how the filament business started and why BASF decided that this was something that they wanted to invest in.
Yeah, so ultimately, I believe it was around the time the 3D printing team was originated or kind of more formalized. At that point, on the filament side, we acquired a company called Inafil. So they're located in the Netherlands in the city of Emmen. They already had an existing portfolio, customer base that they were working with. The goal was to basically have those products and start to add on. So really adding on with industrial manufacturing grade materials that they could bring to the market with the philosophy of partnering with machine manufacturers to offer a solution, but also being able to work with open FFF printers to really bring quality materials to the audience or a wider audience of people, to open possibilities of what people can do. That's
a perfect way to sum it up. And it's all about innovation as well. I think over the past couple of years, we've seen so much innovation from your group. Emma, what's something that, just out of thin air, you'd be like, this was something that I didn't expect maybe?
Yeah, so I mean, I think for me, I tell people every day and they're shocked. One of the things that we have is our metal filament. And crazy enough, it was one of the first things I printed when I joined the team. I had never used a filament printer before being here. And I jumped right in with metal, but it was very cool, very unique, and really differentiates us and makes me really excited to work with.
For sure. And I think that's one of the headline products that you guys have. And also for us to carry that as well. It's been really special, really unique way to implement that in the 3D printing world, especially for open systems like Ultimaker, VCN3D, Raise 3D, that they can start to print these filaments, without an extremely big, expensive system.
Yeah.
Has been a game changer for us. And I don't know if you guys know how big of a game changer it is for the entire industry for you guys to have this, but tell me a little bit about, what kind of behind the scenes research and work goes behind launching any filament that you guys have.
Yeah, definitely. So Yeah, it definitely depends on the product, but I guess I'll use metal as an example. And a lot of our products are based on BASF raw materials. So the metal is based on our Catamold technology, and our flexible filaments are based on BASF Elastolan flexibles. So that's really where we draw from. We try to use these products where BASF has this chemical expertise, and now we need to make it a 3D printing filament, which is the challenge. So we have a research team that we work closely with, and they work with traditional BASF and try to optimize which grades of filament, what additives might be needed to produce a successful product. We start at a small scale extruder to make some lab scale batches, and then eventually it gets scaled up to production. And with all of those steps, it's troubleshooting what issues may arise, and then until we get it perfected and are able to have production quality filament.
Yeah, I think that's a good way to sum up what is probably a much longer, more complicated process, because that's a lot of steps, and small filament manufacturers don't really have all of those standards that you guys have, because you guys have been in the industry for so long. Now, you mentioned some of the polymers that are from the traditional BASF. How does traditional BASF compare to Forward AM? Just as a kind of, if we don't know the two divisions and sides.
I'd say probably with the bigger BASF, they're just larger. So there's a lot more people, there's a lot more in place, there's more established business, there's a different business model. I'd say the simplest answer is we're a newer group. We're able to be a little bit quicker, we're able to be a little bit more nimble. We're bringing different innovation. It is a completely different business model. So, as you can attest, when we work with you and you're working with our supply team, traditional BASF is like rail cars are coming in. This is what people are working with. This is, dollar amounts that they're working with, just sheer amount of product. Where in 3D printing, someone may buy a spool. They may buy 10 spools. It's just a completely different scale that, I think it's the evolution of where we're going, where we can actually leverage a lot of the know-how, the ability, the manufacturing capabilities, the SDSs, the TDSs, really taking that expertise and bringing it to 3D printing, and really kind of driving forward with more of a manufacturing focus.
So why don't we take things a little bit personal and just talk a little bit about you guys. I've known you guys for a while, and it's been great working with you guys, but how did you get such prestigious jobs in the 3D printing industry?
So I started with BASF directly into their 3D printing group about 5.5 years ago. So my experience, part of that is I actually was still in 3D printing, working on the software side. I actually worked for Materialize, representing various software that they had for about 9.5 years. So I kind of did a bit of a shift of, I was still in 3D printing, but I came from software where you're worried about having good files, getting everything prepped before printing, into then the raw material or the filament material that you actually start printing with. And when I started, it was very early in the local 3D printing team in the group. There's me and a couple other folks that were there pre some of the product offerings that we have now, and kind of got into it, liked it, enjoyed the different business model that they had. I liked working with the different materials, the expertise that the colleagues had. And it was a new challenge, and here I am today.
Yeah, so I started working in traditional BASF about 6 years ago. I've bounced around a little bit within traditional BASF. I was working in our photopolymer resin R&D and product development group. And then I actually, because of my photopolymer background, moved into the R&D group working with our 3D printing resins. So that's how that kind of matched up. And then what got me into 3D printing within BASF. And then from there, I wanted, more of a customer-facing role and more interaction that way. So moved once again, and now I'm in my current role, which is in working with our filament products, and now on the customer-facing side. So, yeah.
So how much R&D do you do now versus back then?
Yeah. So previously it was all R&D. It was a lot of formulation, all making working on making new products. now I almost exclusively work with our commercialized products. And so very different. I know what I'm working with each day, and now it's more, tuning it to printers, developing different applications, trying to offer end solutions. So yeah, fewer different products, but way more applications for that.
Yeah, and did you have any trouble switching from the photopolymer side to the filament side?
Yeah, it was definitely very different. So on the photopolymer side, I feel like the materials I felt like on a daily basis, it was much more like chemistry involved, which is my background. But then when I switched to filaments, it was like, whoa, there are so many settings on these printers compared to like DLP or LCD printers. And so that was a big learning curve. I was like, oh, normally I have maybe 10, 12 settings I'm working with, and now I'm changing hundreds. So yeah, definitely different in that regard.
And Ben, did you think that you would end up in, the filament 3D printing space, a couple of years back, or did you think that where did you think 3D printing was going to go? Let's put it that way.
I thought 3D printing was going to continue to advance. So you kind of look at the industry, and I think the machines continue to get better. So, there's new players in the market. You have a lot more printers that are going to be out there. They keep getting better. They keep getting faster. And I think on my end, it was kind of exciting to be part of that because like Emma alluded to, there's so many different things that you can do and so many different materials and so many applications that every day is a little bit different. So you're working with people solving their problems. What are they trying to accomplish? You kind of work your way backwards with it. Whereas I think these days there's just so many solutions and so many tools. It's pretty exciting to be part of.
Yeah, I think you just came on kind of around the time when things exploded and became so much more popular. Did you expect that the consumer who started 3D printing would kind of drive innovation even faster? What was your interpretation of how the public would take 3D printing?
I think it's evolved. Because I know when I started in the industry, again, it was on the software side, but it was, if anyone was 3D printing, we would ask, which of these 6 printers did you have? That's kind of what was there, 6, 7, 8 printers on the market at the time, especially for North America. But now there's just so many different things. And I think with that, machines and materials being so much more accessible to people, it's going to drive innovation. Because someone who has an idea and a thought and wants to try something, you're able to get an affordable printer that can print and give you good results, have a good, reasonably priced material that, you may not have been able to do at one point because it would be a big investment to try something out. So it kind of gives people like a cheaper barrier of entry to try, to fail, to try again, and really come up with some new innovations and success.
Absolutely agree. And Emma, in terms of your day, how many consumers versus professionals or engineers are you dealing with on a regular basis?
Yeah, I would say it really depends on the day, but I have a very good mix of all of that, which is really what makes my job so exciting. So, sometimes you get, like you said, the consumer that has a very unique, maybe more artsy idea that they're into. And then you have the, more industrial person that wants to bring this into their manufacturing space. And so it really varies. And with that come different challenges and questions and things I get to work on each day. So it really makes it super exciting.
You almost have to switch your brain between talking to someone on a normal basis and then go in engineer mode and then...
For sure. Yeah, you definitely have to keep all of this in mind, but then know what to focus on too. But yeah, for us, it's also really great. So for my job, I work in our application technology center. And so I work in the lab and we have all different printers and different platforms. So when these customers come to us, it's also like, okay, now we also need to pick the printer that we're going to work on this problem with. And kind of figuring that out too is always exciting.
So tell me about your innovation center, because I know this just came up about now and I forgot to ask you, but this is a very great perk of where you guys work. So tell me a little bit about what you guys have built over there.
Yeah, so we have a lab space in Detroit, Michigan. And in that lab space, we have all 3 product lines are represented. So we have a lab with our powder bed printers, a lab with photopolymers and DLP LCD printers, and then the lab that I work in, which has all of our filament printers. And so within each group, we are all machine agnostic, and we try to represent what's out in the market, what our customers might be using as best as possible. So that means having unique features on each printer. For filaments, do they have, dual or 2 nozzles, or, different things like that. And then, also ranging from, what you could buy for a very cheap price to more expensive, representing the industrial market. And so we try to really vet out applications on all those printers in that range, and also offer as best as possible plug and play solutions, develop print parameters for each of those different solutions as well.
It sounds like you have a lot of toys to play with on a day-to-day, more than we do even. So I think that's a dream job for a lot of people out there, to be able to test materials on all of this, and to really have that respect for materials, chemicals, and science all in one. Let's talk about filament, because this is why you're here. This is what people want to hear about. First off, before we go anywhere, favorite filament and why?
So for me, it's going to be metal, because it's just the most unique, and it has the wow factor.
I would typically say metal, because I think that's the easiest answer, because it's so different. And the fact that you're able to affordably make actual metal parts, and we've got a partner, DSH Technologies, in place that you can actually send out the parts for the debinding and sintering. You don't need to bring in and harvest that expertise. So if I can steal her answer, I would probably go with our TPUs, our TPU line of materials. Okay. Just because by trade, I'm not an engineer or chemist, so I think they're really cool. They've got a lot of different applications. There's something that you're able to print on more consumer good products and caps and seals and those types of things, and those kind of resonate as things that I find interesting in my life. So I think those are pretty cool. So I'm going to get to TPU, but let's talk about metal first, because that's the big one in the room. When metal first came in, it made a big splash everywhere. Now it's got a little bit of time to proliferate a little bit more. What are some of the coolest applications that you've seen for metal prints, and why people are using metal, your metal filament? Yeah,
I mean, again, we see a wide range of applications. We'll see people that use it to, again, do these more artsy projects we've seen Batman logos get sent in for debinding and sintering, and we're always like, oh, that's pretty cool. What are you using that for? But then on the more industrial side, we'll see smaller, jigs and fixtures, or just if someone needs smaller replacement parts for something, prototyping for traditional manufacturing as well. You can really get in there and customize the metal to, how you want it to be before you have to take it to a traditional manufacturing scale.
Yeah, and I think, for those who are joining us and haven't printed with metal, we're really able to do it for a very, very low cost with your filament versus traditional means of getting your own debinding and sintering process, which you still have to be an expert at it, and it's not easy. So with this in mind, and with this much lower barrier to entry and lower education level that we have to have in terms of not needing to learn how to debind and sinter it, where do you think it might go in the future? So right now we have 2 materials. Where would you like to see this proliferate? Do you want to see it go into more industries, get more certifications? Where do you think we'll be with metal in the next little bit?
I think it's going to continue to evolve. So I really think it's a case where people are starting to better understand what metal is. Because I know when our product first came on the market, it's like, okay, I can print metal. So I would get people that would call me and they'd say, okay, I printed your part, it's not metal. It's like, no, it has a secondary process, and they didn't understand it. Or I remember, it's kind of shocking to think of now, but a couple times people would call and say, okay, I have this, I wanted to bind and sinter it myself. What temperature do I need to turn my oven on to? I'm like, okay, do you have a lab oven? They're like, no, I'm at my house and I want to put these parts in the oven. And it's like, no, it doesn't work that way. So I think it's really, as people are starting to better understand how to use the material, or just metal filament or metal extrusion printing in general, and understanding that what you're going to do and what would work for a PLA that design may or may not work for metal just because it's got to go through the secondary processes. So I think even within that, there's a lot of improvements just over the last year and a half. I think the parts we're seeing coming in and things that a year and a half ago we would have said, you're pushing the boundaries, it's probably not going to work. And now people are exceeding it every day. And it's just exciting to see that because it just continues to push it farther and farther.
And I think a lot of that has come with, the partnerships that you guys now have with some of the manufacturers where, they're offering your filament now on a more first-party basis. And I think that's changed the talk and conversation about that a little bit more. Have you seen a greater adoption and a greater acceptance of metal 3D printing because of this process? And what could we do, or what could you guys do in the future with your partners to get even closer so that, it could be even more seamless?
Yeah, so I think with the working more closely with the machine manufacturers, it only benefits the entire process. And I think what really helps is, even though we are saying, you don't need these like large systems, you can print them on your printer, metal printing, it does involve more steps than printing with, your commodity products. So it is harder, and has, a larger barrier to entry, but what working with the machine manufacturers does is it lowers that, and it makes it so you have all the supplies for that specific printer that you need to successfully print a metal part, send it out for debinding and sintering, getting it back, understanding the process, learning about it up front. So it really just lowers that barrier to entry and increases the knowledge of the end customers.
Yeah, and I think, you guys are a manufacturer, but one of the things that we've had to learn together is the education level required to tell someone about, what 3D printing metal, entails and what the process is, as we were talking about. How has BASF evolved to supply a lot more information and to educate your customers, our customers, on printing metal filaments?
I think a lot of it is just experience. I think at this point, like it was mentioned, working with machine manufacturers, I think you now start to offer more of a solution. So you're not losing the freedom of people to have access to the material, to use what printer they want. I think they're just making it a bit more seamless in what's going on. And I think like talking today, or like what we've done, earlier today, is just, here's the realistic expectations of what you can do. You're not kind of saying, hey, you can print anything, anywhere at any time and it's done. It's really being honest with people, saying, hey, this will work or this won't. People will call us and show us designs and we tell them, that's just not going to work. Here's why. You can tweak it, you can alter it, you can do some different things for it. So I think really setting their expectations for that to set them up to succeed is really where things are starting to move forward, because if your first 5 prints are failing, it's a little discouraging. So I think really kind of setting people up for their own success is overall going to make the metal filament printing a success.
Yeah, I think you guys have done a lot of work in terms of upgrading your portal, your website, providing a lot more guides, and Emma, a lot more instruction on how things work to make it a lot more of a seamless process. I think originally it was just like, it's here, go, what do we do, right? And now it's like, here's how we're going to get from, A to Z and get this metal part. And, we really applaud all the effort that you guys have put in as manufacturers to help people get to that stage where we can pretty reliably get these metal parts the way that we expect them. And that's pretty amazing for such a short amount of time. So enough about metal for now. Let's talk about some other filaments. Maybe we'll start with some TPU, and then maybe some of the filaments that you want to bring up that might be your personal favorites, and then maybe one of my personal favorites. So TPU, where are we going? What do we have now? What's so special about it?
Well, I think one of the benefits our TPU has is just the BASF expertise. So as we talked about earlier, kind of what are some of the benefits of being part of the world's largest chemical company? It's some of the expertise that they have in ability to source different things. So in this case, our elastalon, that's something BASF really does excel in. And whether it's with our powder materials or our filament materials, we're able to start bringing over those different aromators of materials, getting them set up so they can actually start being used for 3D printing, just because there's a lot of real world applications where that's needed and it can excel.
Yeah, and what traditionally would elastalon be used for in the real world. And I guess the filament allows us 3D printing prototypers to kind of get really close to that application.
Yeah, so for traditional lesson, there's so many applications, but you might see these flexible TPUs in shoe soles, or it could be like for different consumables, wearables, like a watch band potentially. And then also your more industrial applications, like gaskets and things like that. And really on the 3D printing side, we can start seeing very similar applications that we would use our 3D printing flexibles for as well.
Yeah, I think that's something that a lot of our engineering customers have asked for. You know, they're an auto manufacturer. They said, what's the closest to this? And you guys actually have almost the same material, you know, sourced from the same raw materials. And I think that goes a long way in terms of entering that engineering space. Aside from TPU, Emma, what are some of your personal favorites and noteworthy mentions in your portfolio?
Yeah, definitely. Another one that I really like working with would be our PLA Pro 1. That's our modified PLA. It has better mechanical properties. You can print it faster, has, you know, great surface finish and just really easy to print. But, you know, for me, if I'm going to choose PLA or the Pro 1, I'm going with Pro 1 because it's just as easy to work with, but yeah, it just comes out so much better. And yeah, I really like how all the prints with that turn out so nicely, and I really like that aspect. So
yeah, I think we've been working with Pro 1 for, I don't know, 6+ years, and it's been amazing. Every time we print it, we tell everybody it's the next level PLA. So you've absolutely sold us on Pro 1, and I think a lot of customers as well. What about some of the composites? I know we talk about advanced materials a lot, and there's a lot in your portfolio, but composites is a big part of that portfolio. You've been increasing the number of carbon fiber, glass fiber filled materials that's available. First of all, what are your thoughts on composite materials, and then what stands out in your portfolio?
I think on the composite materials in general, I think it kind of falls in line with those engineering grade, manufacturing grade. I think that's really where the shift is starting to go for 3D printing, especially with a lot of the filament 3D printing. If you look at where people are starting to push forward, where they're looking for end use applications, where they're really going to start getting to manufacturing, they're starting to get into those types of grades of materials just because they need the material to be able to perform better. So, you know, I think a novelty of having, hey, there's a 3D printed part, it doesn't do anything if it doesn't work and do something. Right. So I think that's the key, is getting those in, whether it's carbon fiber filled, whether it's glass filled, anything that we could do, high temperature materials, to really kind of get people, ignore the shaping factor, whether it's injection molding or 3D printing. You need a material that's going to be able to perform, and that's where we're really trying to push those types of materials.
Yeah. You guys are very serious about materials, and I think people need to know, you know, that you're serious and how that impacts the final product, which is a very good, very noteworthy product in the industry. In terms of carbon fibers, glass filled, do you have a preference, carbon fiber or glass? And what really is the difference between those two materials?
Yeah, I don't know if I have a category preference, but we definitely have our product favorites. I think probably for me, out of all of them, our PAHT Carbon Fiber 15 is my favorite in that category. It has really great mechanical properties, high heat resistance. It performs well, but also looks nice. So we like that. And it's not super complicated to get a difficult or a high quality looking print either. You don't have to, I don't know, tweak a lot. Yeah, it's not a difficult material to work with for all those advantages that you get. Yeah, and then some of the differences, I mean, yeah, between carbon fiber and glass fiber, each product is gonna have, you know, excel in certain areas. And so really the way I look at it is, with my scientific background, is like, okay, what are we trying to achieve? And then let's start looking at mechanical properties, specs we need to hit, and yeah, they all have their advantages.
Yeah, I think PHT is my personal favorite. It's just so stiff when you print your part, and being heat resistant is something that people ask for often because their applications are close to a motor or something like that. I think that's something that's getting more and more common, and that's why they look for more engineering grade materials that can perform better. And that is a great example of one. In terms of composite materials, I think one other noteworthy one that I like a lot is PETCF. It doesn't get spoken of that much, but can you tell me a little bit about what are the properties of that particular material, and is there something unique about that one?
Yeah, so for the PET carbon fiber, that one is by far the easiest to print of all of the composite materials. And so like I really try to tell people if they're trying to look for that next level, they need some better properties, want a more engineering grade material, I definitely lead them to that one first. I tell people if you can print what you're currently printing, I promise you can print this too. So I think just ease of use, and then it has a really nice surface quality as well. So it still looks, really great. And yeah, you can just use it for these more advanced applications that you need these engineering grade materials for.
Yeah, and I think one of the things that we don't talk about a lot, and haven't talked about it yet, is water-soluble materials and support materials. BVOH, pretty darn famous here at Talk3D. But what is your guys' take on BVOH, and why have you made BVOH and not a PVA, for example?
Yeah, so for BVOH, we also love it. So it's one of our support materials, but it's water soluble. So really, you need warm water and you can get rid of that support. It's compatible with a lot of materials, which is great. And also it means because it's water soluble, you can have a very complex, intricate geometry. You don't need to get in there and break that support away. You can just dissolve it. So it allows for a lot of design freedom and creativity.
Yeah, and PVA doesn't traditionally work with ABS, but BVOH works with your ABS fusion. So that's like a unique capability that you guys have unlocked for us, because now we can use ABS with a water-soluble support, which we couldn't do before. ABS fusion, tell me a little bit about the secret ABS formula that you have that does work with BVOH.
Yeah, I think ultimately it's going to be a modified version of an ABS. I think ultimately the end goal with it was to be able to get something that would have better performance properties than something with an ABS, but also be able to be easy to print. Because I think at one point when it was coming about, I think that was the goal, is basically have something where you can have someone who's more of a novice user of a printer that's going to be able to print. They maybe aren't going to go up to a glass filled or a carbon fiber filled, but they need to have that niche or that space that's in there for performance needs that they're going to be able to do, and they're going to be able to print with it. And I say in our portfolio itself, it's more popular than our ABS. I think customers like it more because it's easy to print. You're getting the better mechanical properties, but then going back to the BVOH, the fact you have a water soluble support kind of gives them the whole package, especially when you add in it can print on basically all printers.
Yeah, and the surface quality is really nice on the ABS Fusion, so big bonus there for ABS. In terms of picking some of these advanced materials, I know you guys probably aren't the ones to choose it, but do you have any idea how BASF chooses their next specialty material, or is it a secret?
I would not say it's a secret. There's definitely going to be a lot more that goes into it than what I'm going to be describing, but really, we try to see, again, I feel like we're leaning more and more towards, drawing on traditional BASF products in our new products. So that's definitely something we now focus on. And then also just seeing where gaps in our portfolio are, gaps in the market as well. And then again, even if we have this raw material and we have this gap in the market, we need to make it into a nice usable filament. So then that also can weed out a lot of things. And we kind of go from there.
And you guys sell filament all over the world. What are some of the challenges of being so global as a filament manufacturer?
I think part of it is just different regions have different expectations, and I think it's global. So making sure you get everything where it needs to be when it needs to be there. So with that being the case, making sure that you're able to have local stock for your local regions. So that way, if you're supplying them material, they have customers that are coming up, that you're able to get it, secure it, source it, and be able to provide it for them. In the various regions as well, I mentioned the different expectations, but some of that is there's just something that I think BASF does really well, and hopefully you agree, is kind of looking at some of the different, SDSs, TDSs, making sure things are in the appropriate languages for people, making sure local regulations are adhered to and met, and those types of things, is taking those into account, making sure that we're meeting and exceeding expectations for each region, just because it can definitely be different.
Yeah, and I know sometimes you say that BASF can be slow because you're a big company, but when I imagine that this is going all over the world to hundreds of different languages and regions, different humidities, different warehouses, I mean, that's a lot of work. That's a lot of logistics. That's a lot of organization. So absolutely don't think you guys work slow when you take into account all of that.
No, it's a little bit of a blessing and a curse. I mean, when you kind of think about it, because it's this big global leading chemical company, and they do what they do, so they're sending out rail cars and they have expectations in the way that things should be done properly, but it's all being done with a focus on end use for manufacturing and engineering. So they're transferring some of that over to our 3D printing team. So for us, sometimes we say it goes slower, but we know really what they're doing is they're taking those steps and those procedures to make sure that we are meeting the expectations of customers and users, to ensure everything is in place to support them and actually moving themselves towards getting manufacturing applications.
Do you think that customers who have dealt with BASF on the manufacturing side take a look at your filament and almost hold you to a higher standard because of that?
I would say yes, simply from the aspect, it's an educational process. And so in some cases, some of the traditional BASF end customers have 3D printing teams, 3D printing labs. They're ingrained and they're in it every day. But I think at other times you're working with folks and they're used to traditional manufacturing. So they'll give us the line card for a material and say, I want to meet and exceed and hit all of this. And it's like, it's not quite the same. So if it was the same, you wouldn't be talking to us, because you injection mold or you use your traditional manufacturing methods. It's really finding those applications that work, talking with them, trying to find a solution. Why do you need this? What can we do? And working back. So I think from the material side, yeah, they expect high quality material. But then I think from our end, it's just a different approach of making sure you're kind of partnering together to tackle a problem.
Right now, it does seem like, from how you're saying it, Forward AM is like a very small section of BASF. If I were to project X number of years in the future, when do you think you'll be a more significant part? And how many people will be in your division by then?
Oh, wow.
This is just a guess.
I don't really have an answer. I think we're growing. And I think the more that the industry grows, the more that people are continuing to see the benefits, I think it's going to continue to grow. So I think one of the things that we're starting to see a shift, and I think it'll continue to be a shift, is we're the 3D printing team within a bigger company. I would imagine it'll start to be a little bit blurry, because I think you can almost be a complementary technology. So when you're going to a customer and you're talking to them, okay, what problem are you looking to solve? And you start to go through the options of different materials, different things you can do, 3D printing becomes one of those options. Like, we could do this, but instead of making two parts and having to adhere it or weld it, why don't we print it? Right. So I think it'll get more ingrained into BASF, in general, just because you're offering solutions to that market and you're just kind of like another bow, in the bag that you can start to use to solve and tackle problems.
That's a great answer. Very reasonable answer. Just before I end things off, between UltraFuse, UltraSint, UltraCure, is there, challenges? Do you guys compete with each other, or is it much more cooperative in that way?
It's definitely much more cooperative, I would say, overall, at least. Like I said, I'm in the lab, and every day and with other people working on the other technologies. And if anything, we get, maybe slightly jealous, but also really excited when someone has a really cool new application or cool new product that they're working with. Generally it's just excitement, and the jealousy is just that we aren't the ones that physically have our hands on it.
That time.
But in general, we're definitely supportive, and we want to find the best solution for our customer. So that's really where it comes in, that I can ask the person at the desk next to me, like, hey, would that work better for this application? And we can really work together to figure out what that is.
And you always have that answer regardless of technology and printer at that point.
And that,
exactly.
And that's the key, is a lot of times we'll have people who come to us and ask, hey, we're looking to do this. Typically I'll reach out to, kind of the powder equivalent to Emma's role, say, hey, do you have this? Or I'll do the same with our photopolymers, and we'll kind of see what they have. Truly, because each of those technologies, there's benefits and less benefits to each of them, and really finding what works for everybody. And then really, I think at the end of the day, whether it's within BASF or just the 3D printing in general, I think any success is good success. Because I think it's not necessarily competing like, oh, use our filament over your photopolymer here. It's like, okay, find a solution so people are starting to talk about, they're looking at 3D printing. Because the more I think that can become mainstream, is seen as a viable option to solve people's problems, no matter what technology is doing it, I think it's better for everybody.
I absolutely agree. We want the industry to grow and not just ourselves.
Absolutely.
So great. With that, I think I'll end it off. So thank you for joining us for another episode of Talk3D. This is Ben and Emma from BASF.
Thank you.
Ben.